Now we go to problem 912. Right, so you have this state of stress of like this, right? And then the question asks you to find the equivalent state of stress if you rotate this 50-degree counterclockwise, right? And the question asks you to use the stress formation equation. You can use Mohr circle as well, but here we're going to just use the stress formation equation. Okay. So please understand this. Initially, this is x, right? So what you do is you rotate this to x prime, the new axis. Okay, this x becomes x prime, and you rotate it 50-degree clockwise. Counterclockwise, right? So you need to identify this. What are these? 10 and 16. Okay. So if you say that this is x, this is y, so your sigma x is minus 10 megapascal. Do you understand this? Minus megapascal, minus, okay? Compression. How about your sigma y? Sigma y, 0. Isn't it? No sigma, no normal stress in y direction. And your tau xy equals to minus 16 megapascal. Why minus 16? Because you see the one which is on your right hand side, it is going down. Okay, from x to y. So x, opposite x to y, opposite y, it is going down. Okay, so it is minus 16 megapascal. Alright, and then you use the equation. It's very simple. So to find this, the one which is along the x prime, which is 50-degree counterclockwise from x, which is theta. In this case, okay, forgot to mention. In this case, your theta is plus 50-degree. Again, is plus 50 plus because the direction is counterclockwise, isn't it? So counterclockwise is plus, and then 50 degrees is the angle, right? So you transform this from sigma x, it becomes sigma x prime, right? So your sigma x prime, okay, is how much? Sigma x, the average sigma x plus sigma y divided by 2, isn't it? Right? And then plus sigma x minus sigma y divided by 2, right? Cosine 2 theta, cosine 2 plus 2 times plus 60, right? Plus tau xy plus tau xy, which is minus 16, okay? Sine 2 theta, sine 2 theta, which is 50, right? So your sigma x prime is simply minus 19.89 megapascal, right? Next, your tau x prime y prime, okay? What does it mean by that? It is the one which is along this, okay? X prime, y prime. Of course, your y prime will be this, which is 90 degrees from here, right? 50 plus 90, isn't it? Your y prime. So, what is the equation? Tau x prime y prime, it is minus sigma x minus sigma y divided by 2, right? Minus sigma x, sorry, this is plus, sorry. But this one minus sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2. Sorry, I mix up the equation, sorry, that's why. So your tau x prime y prime is minus sigma x minus sigma y divided by 2, right? Sine 2 theta, okay, plus tau xy, which is minus 16, right? Cosine 2 theta, which is 2 times 50. Okay, so your tau x prime y prime is 7.7 megapascal positive. Okay, now you have found this, you have found this, okay, the normal force, normal stress, sigma x prime, and you have found tau x prime y prime, which is the one which is this one, okay, the shear stress. But how about the normal stress along this y prime, right? So you can do this sigma again, put it into the original equation. Sigma again, you can name it as x double prime or y prime, whatever. Okay, so here, for instance, if you name it as sigma x double prime, okay, use the same equation, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine cosine 2 theta. Okay, and your theta now, how much is your theta? Theta is from x to x double prime or y prime. Okay, so 50 plus 90, which is 140, isn't it? Okay, and what else? Plus tau xy, which is minus 16, right? Sine 2 theta. Again, theta is 140 from x to y prime, isn't it? 50 plus 90, right? So your sigma x double prime or sigma y prime, whatever, is 9.89. So you have 9.89 megapascal. Okay, so you have this, and you have this. So when you plot them, right, basically from your original x, okay, now it becomes x prime, isn't it? Which is 50 degree counterclockwise. So what you have on this surface, you have tension of compression of minus 19. So you have 20 megapascal compression, isn't it? Right, and then of course you have this as well, 7.7, which is going up. Okay, 7.7 megapascal. Okay, why going up? Positive, going up along the surface. Okay, and then for this surface, okay, that you rotate 140 degree, you have this 9.89. Okay, so you have 9.89 megapascal. Okay, same here, and then of course here you have this same 20 megapascal, 9.89 megapascal tension, and then you have the shear of 7.7, so you have the complementary. Okay, then so this is your state of stress. You can solve it by using Mohs circuit as well. Okay.